So in 4.1, it's all about different types of angles. We've talked about degrees, we've talked about degrees, minutes, seconds, we talked about bearing angles. So now we're going to go to one more for the day, and probably throughout our chapter this will be the most important one, and that is what's called radian measure. So we're going to use radian measure. We're going to try to get used to it a little bit today. It'll be an ongoing process, so don't worry if you still think in terms of degrees for the most part. It is okay, but I want to show you in these next few examples how we convert from our understanding of degrees to radian measures. Now, first of all, the definition of a radian has a lot to do with what's on this picture right here. So you'll notice that this is a slice of the circle. We call this a sector of the circle. And we've got this arc. So if we're talking about 1 radian, it's the central angle of a circle, but 1 radian is the angle that's across from an arc that is exactly equal to the radius of that circle. So here's what I'm going to do is I'm going to think about, what if I were to lay a piece of yarn from the center to the circle. We've got this piece of yarn length, that's the radius of that circle. Now take that yarn and just sort of lay it around the edge of the circle. That'll be the same length as what the radius is. That's what it means to have a radian measure in that one as far as angle goes. Now we're not always going to think of it like that as we go through this. We're going to develop some shorthand to make it easier to think about in our minds, but want to just raise the question then, if we know that we take this little piece of yarn and we set it on there, how many little pieces of yarn go all the way around that circle? Now the way that we figure this out is by consulting the formula for circumference of a circle. So I want to know what the circumference is. You may remember that from geometry, but the circumference is 2 pi r. That's the formula for it. So saying that the distance around the circumference is 2 pi times whatever that radius is. Now this is going to be what we use for radians, and so what we say is that if you go an entire turn around the circle, which we know to be 360 degrees, that's actually going to be the same thing as 2 pi because of the fact that we had 2 pi times the radius. So 2 pi is equal to 360 degrees. Now, so we've got the one there. So we could think about this one as either 0 degrees or 360. So we go all the way around as 360. But what if we go just part of the way for these other things? We can start breaking these into different fractions. So if the whole way around is 360, that means that half of the way around, so half of a circle is 180 degrees. Well, we cut this in half too, and so pi is equal to 180. So if I go over here, right over here, this is 180 degrees, which is the same thing as pi. And I could cut that in half again. I could do more fractions of that, and I could go to here. Now this one is 90 degrees. Cut that in half again. So if we do that just looking at the fractions here, just thinking fractions, then cutting pi in half is going to be pi over 2. And there are going to be lots more fractions that we'll use related to this, but that's pi over 2 or 90 degrees at that spot. And so as we go along here, and in the next example, you're going to see how we, in general, convert from degrees to radians and vice versa. That's going to be a skill that we'll use quite a bit at the beginning, and then hopefully as you go through, you'll start to think in terms of radians, and it'll be more second nature to you after you've seen a lot of problems.